All right, other thing we got to do with vectors is we got to be able to scale them up. So if I have a vector like v, and it's like at 3, 7, oh, that's kind of big. Let's make him not so big. Let's say he's like 3, 5. And I can start this vector anywhere, so I'm going to start him here. Okay, and then 3 is x, and 5 is y. 1, 2, 3, 4, 5. Start point to the end point. That gets me vector v. If I want 2v, keep in mind that it doesn't matter where this is. I can have 2v be anywhere on this graph, but since I already have v sitting there, I'm just going to count it again. From the end of that, now, from the start here, maybe I'll make it a different color here. From the start here to the end is now 2v, because I have 2 of those. You can think of it as component form too, because if it was 3, 5, now this should be 6, 10. And if you count this out, you do get that 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's one scalar. The other scalar we got to look at is what if it is wanting us to do negative 2v. Oops, negative 2v. So you can think about it in our component form over here. It would mean that this is negative 6 and negative 10. But part of what you're going to have to be able to do is represent it on a graph too. So if you have a starting point, regular v was 1, 2, 3, 1, 2, 3, 4, 5. Really, what negative v does is it switches the 3 to be negative and the 5 to be negative. And so essentially, I'm going negative 3, negative 5. Which essentially means that if this was v, I guess technically if I make him purple so it matches, if this was v, then what negative v does is it basically just flips that around to have this starting point and going down that way. That's negative v. And if I want negative 2v, 4, 5, 1, 2, 3, then I get this guy all the way here. And now I've got negative 2v. And what you might have to be able to represent also is that we could add 2 things together with a negative scalar. So maybe we'll get another one here. We'll keep v, but let's get another one here. Oops, it was already red. So let's say I have w, and it is at 4, 1. Not at, but it is going 4, 1. And let's say I want to graph 2v minus 3w, and I want to represent that on a graph. Well, I need to start with the 2v. So 2v says, okay, start here and go 1, 2, 3, 1, 2, 3, 4, 5, but then I got to do it again. 1, 2, 3, 1, 2, 3, 4, 5. Oh, I'm getting too close to the edge. Let's start that in a different place. All right. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. Do I not start that in a new place, guys? Sorry. All right. One more try. Let's bring them down a little bit. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. Okay, but technically there's no arrow there, and we've got 2v. Biggest thing to know about this guy with subtraction is that we aren't going to really think about him as subtraction. We're going to think of him as adding a negative 3v. So we're going to start on the end of this, and we're going to add a negative 3W. So W was 4, 1. Like I just said, that negative basically switches them around. So we're going to go -4, -1. So if I grab my green here again, I'm going to go from the end of this and go -4, -1. There's 1 W, negative W. And 1, 2, 3, 4, and down 1. That's 2 of those. And then 1, 2, 3, 4, and down 1. Now I've got, so this is -3W, and this is 2V. And I need to add them together. So when I add them together, I go from the beginning of the very first thing that I did over here to the end, and I've got that vector right there. Represents 2V plus -3W or -3W. You can totally do this in component form over here. You could just say, well, 2V would be 6, 10. And if I need to subtract, we'll go back to subtract here. Subtract 3W, that would be 12 and 4. And if I subtract those, I get -6, -6. Nope, -6, +6. Sorry. -6, +6. Because I'm going 6 minus 12 and 10 minus 4. And if you see that over here, this actually says -6, +6, because this is my starting point, and I'm going 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So I can get it in component form and graphically.